Welcome to another episode and video on my Arduino MegaADK. Originally for Android, but my Android is too old. As well as breadboard with electronics and visiting Mechatronics. Last time, or the episode before that, I decided to start all over again. Not to rewire, but to reprogram and see whatever happens and maybe why. And things don't go nice. I tried to get this one running. Well, this is the plot meter that regulates the speed for this one. How does it work? Well, if everything alright, this is ground, this is power, and this is actually a variable resistor. By turning it, you change the voltage, which goes straight to the input, and the input is the actually the output to this. And it would be nice if I have a screwdriver in hand. And here it is. So I turn this one. And well, so far nothing happens. So I get the serial monitor with it after checking the correct board. And then well, the value does change, but apparently not of much influence. So this could give some rust. Another thing is this part of the circuit. RC combination, resistor, fixed resistor, capacitor. Pressing this button should make it flash, but it keeps burning, which is odd in itself, but so be it. So why does it happen that way? It should just give a little flash. That's a matter of wiring. But how it originally was is that it lit this LED and a motor, and that went wrong, very wrong, because the motor didn't work at all. I tried with a switch, didn't work. However, the worst part was that, and still is, that the ports don't give the value given. So if I give a value of 256, which is the maximum value in port modulation, then using constant integer declaration, it doesn't work. If I say port 7 will be input or analog in pin 7 or analog output 7, I should be able to give 256 actually to that port, and that is not working. So why is that? I don't know. It's been going on for some time, but that is the problem right now. This one doesn't really work. This works, this one works, and fortunately now this one works as well. This one doesn't work anymore because it is not connected anymore here for some reason. And that is the state of it right now. This doesn't work anymore, strangely enough. So, does it make sense to go on? Well, I want to know why. I want to know how I can fix it. So yes, I'm going on. So let's see on the screencast how I can fix things, if possible. So, step by step or chaotic. I can do both. Now, one of the things that matter is that the pulse modulation is depicted here, which is from the motor, is a bit weird. Now it runs very fast. It didn't start, as you could see. And the reason, I don't know. What I do know is that quite at random I looked at the schematics, and then with no particular idea, I looked at the voltage divider and found that it was no longer connected. So where does the voltage divider connect to, apart from the phototransistor, which basically is a binary switch, so it is either 1 or 0. It connects to A4, and indeed A4 was blank, was empty, so I reconnected it, and it is connected to this voltage, to this phototransistor right here. So what does it do? Well, right now nothing. So what I should do is making sure that I can read something. Alright, so this is input from voltage divider. Phototransistor. That being clear, and according to the schematics, I can, well, it's not quite in line, but let me just say, well, this is A4 of A5, A7, let me put it right here in front of this. So serial print, and then analog in pin A4 is, and it will be a print line. And now what do I do? Well, this is digital read, and is that indeed done? Constant I only have to read, and this is declared analog. Oh, analog in pin. Is that indeed analog in? That is a fair question. If I get nonsense, that's a fair question. Is it analog? Because it's from a digital switch. Well, I can always try. Analog read. from analog in pin, because otherwise I have to change everything to digital. But let's just see. So everything is set to ADK, that's good. Let's go. Done. $682. Alright, 687. So what happens when I cover it up? Nothing. Release. 686. Cover up. 87. So what if I change this into digital? Or is A4 always analog? Because I know that the normal pins can be in and out. Good. That's a good one. And in another perspective, what is this number anyway? Is it voltage? I can only check that by putting a probe, the purple probe, to it. Right here. There is hardly any change visible. So what I am going to do now is actually selecting 3, as you can see here, and then turn up the voltage, or actually turn down the voltage. Half a volt. So now actually this range is half a volt. What does it generate and when? There should be some difference. Yep, it's most definitely a phototransistor, but the signal that it gives, okay, that should then be digital. So change this to some other port or redefine the whole interface. So constant integer digital in pin A4 can even be done. I really don't know. It's A4, and then this one goes out for a moment. Okay, let's first compile this one. it won't work because oh yeah, why compile if it won't work? So this will be digital read, and this will be digital in pin. Now I'm very curious what will happen. Okay, it is accepted. Now it's 0. And it stays 0. And okay, there's no difference. So what if I shine with a lamp on it? And no lamp. Lamp. No lamp. Well, that's a difference. And now it is half a volt. So when it goes up, it's one volt. Oh. Okay. Quit it. Now it's 0. I have to do something else about it. This is not good. And I don't want to ruin more electronics than I already have. Alright, so I have been thinking about analog versus digital, and I changed the digital A4 so now it's analog again. I uploaded it, and point is as well, using this flashlight, then you can see that the purple line is going up. Currently one cell is half a volt, so here it is 1 volt. It can, a port can have about 3.5 volts, no, slightly less. But also needs to be said that digital 1 is not 1 volt. Digital 1 means that the analog value is higher than a threshold value. So for instance, if you have 3 volts, then usually say 2 volts is a threshold, or it can be 1.8 volts being a threshold. Everything over 1.8 or anything over 2 volts, whatever the threshold may be, that is considered as 1. Everything under, say 1 volt, is considered 0. So that is also the reason that you see several values or one value, but what is it? So once again, shining. What is 4 doing? Absolutely nothing. Oh wait, it is now 690. I'm removing it. Wait. 685. That is not a big difference. Not a big difference at all. So, what is wise to do? Well, basically I want to change A4 as an input to one of the other ports that is available for pulse modulation, for example, let's say 4 or 13, and make that a digital input, and then I can indeed test whatever is going on. Is the voltage divider still necessary? Well, a voltage divider lowers the value, of course, it lowers the voltage, so chances are that it then doesn't reach the threshold, but we will see then. What is the threshold anyway? That's a good question as well. Okay, let me change the value back to, oh, that's lower. Okay, now a cell is 5 volts again. Oh, it's now 10 volts, that's not the intention. 5 volts. And if I shine on it now, oh, look at that. So the light from, oh wait, you can't see it, oops. Now look at, so now you see the purple line. Yeah, on the camera it doesn't look really purple, but it is this line. Oh, that is too bad. Maybe the batteries are going out, but you can still see that the line is going up. And okay, it's bright again. So it is, yeah, it does work. But would digital be better? Through the voltage divider, I have my doubts. So will this be regarded as 1? I have my doubts. What I can do, of course, is plug a second wire, put that to, say, port 7, which is free, and see if that gives 1. So let's do that. Plugging in a wire. I need pliers for this. So here goes. And then it would be nice if it indeed goes in. Twisting the wire to give it some robustness. Question is, does it work? Yes, now it works. Then I need to find a socket. Well, let's use 7. Alright, 7 it is. And then program it. Pin mode 6. Okay, pin mode 7 it will be. 7. Oh wait. Yeah, this is input. Oh wait, this is all output. So I will say pin mode 7 is input as well. that will be digital input. Then right here, const int digital in pin 7 is 7. And how will this continue? Well, I have now 7, so let's do it right here. No, I will do it right here, straight after A4. So I want to copy things now. Copy and paste. Digital in pin 7. This will be a digital read now from digital in pin 7, and I'm now very curious if it will hit 0 or if it will hit the 1. So upload, done, and let's see. Okay, so what is it doing now? Digital in pin 7, 0. So in comes alright, let me show you. So I'm shining. Oh, see, digital in pin 7 is 1, and letting it go now, it's 0. Right now it's 1. 0, yes, and 1. And but what is analog in pin 4? Strangely enough, that doesn't change much of value. 690. But it clearly, very clearly shows that it is a digital port, varying between 0 and 1. And that's very nice to see. So now I need to change this one, because not only does it go to here, 9 is not connected, so is 7 not connected. Oh wait, 7 used to be here, controlled by photo. Okay, so there was an LED and I wondered about that. So this solves a mystery to me. There was an LED of which I was not sure, which is, by the way, this LED, of which I wasn't sure what it did, but it was controlled by pin 7 as an output. Now it has become an input. So this will go away for now, and it will go right here. And your wire going right here. So it's going to places now. Analog versus digital. Add text. And Then of course the question is what to do with this one. Well, I can do something clever, removing it here, and save that for next time. But now I know that this one is working, and this one will be working again. This is still very high speed working. Yeah, you can see so already. Chain is moving rapidly, but I'm gonna let it be for now. And that's it for this episode. So no RC circuit, not much of the Mechatronics, but fischertechnik phototransistor being rewired to both analog and digital, and it works, which is nice. Thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, like it, and please leave a comment or suggestion. You can also follow me on Twitter. Please retweet, like it, leave a comment. You can also follow me on Instagram. Please like and leave a comment. You can also show your support by making a small donation. You can also choose to become a patron and have your name mentioned as a supporter. Very much appreciated. Your name will be mentioned on my website as well as with my videos, depending on the pledge you make, but more information on my website and on the Patreon page. And this is of course going to be continued. So once again, thank you for watching, and bye bye.